Good afternoon, children. Today I am going to tell you about the trends in the modern periodic table. But before starting trends in the periodic table, let us only see the advantages which modern periodic table have. When I was teaching last time, I have told you that the objections which were raised in the Mendeleev's periodic table that has been only clarified in the modern periodic table, like position of isotopes, like clarity about the anomalous atomic pairs. Beside that, all the objections which Mendeleev periodic table had, that has been only removed. Now, the modern periodic table is easy to remember. The properties of elements can be predicted from electronic configuration. Large number of new elements which has not been discovered so far, their properties has been predicted in the modern periodic table. Beside that, in the modern periodic table, the position of anomalous pairs that has been clarified now, and the position of isotopes that has been clarified. Now I will tell you trend in the modern periodic table. There are large number of trends which can be only given from the modern periodic table. We know that in the modern periodic table, elements are arranged according to increasing atomic number. The physical and chemical properties of elements depends upon its electronic configuration. It depends upon the number of valence electrons. What are valence electrons? The electrons present in the outermost shell. If we move in a period, there is a change in the number of valence electrons as we move from left to right. As we move in a period, there is a variation in the number of valence electrons as we move from left to right. Of course, there is a increase in number of valence electrons. But all these valence electrons are present in the same shell. For example, the atomic number of lithium is 3. It is having 1 valence electron. After that, when we move to beryllium, its atomic number is 4. It is having 2 valence electron. When we move to boron, it is having 3 valence electron. When we move to carbon, it is having 4 valence electron. They are all present in the same period, but there is an increase in the number of valence electron. So there is a variation in the physical and chemical properties. When we move in a group, the number of valence electrons that remain same, the number of electrons present in the outermost shell that remains same. For example, the lithium is having atomic number 3, it is having 1 valence electron. Sodium is having atomic number 11, its configuration is 281. Again, it is having 1 valence electron. Potassium, its atomic number is 19. It is having also 1 valence electron. So the number of valence electron is same. So that is why the chemical properties in the group is same. There is a variation in the physical properties as we move from top to bottom. There is a variation in the chemical properties as we move from top to bottom. Now, one of the trend in modern periodic table that is represented by valency. That is represented by valency. Valency is the combining capacity of an element. Valency is the combining capacity of elements. When we move in a period, the number of valence electron increases. In a period, the number of valence electron become 1 to 8. So, the valency is up to number of electron 4 in the outermost shell. The valency is same as the number of valence electron. Again repeating, in the period, the number of valence electron are increasing from 1 to 8. The valency up to 4 valence electron is equal to that of a number of valence electron. As we move further, the valency becomes, the valency becomes 8 minus number of valence electrons. For example, if the number of valence electrons are 5, the valency will become 3. If the number of valence electrons are 6, then the valency will become 2. So there is a change in the number of valence electron and valency after 4 valence electrons. But in a group, the number of valence electrons are same. So the valency is same. The number of valence electrons are same. So valency is same. Now, when we move in a period and we see the trend of valency, the valency first increases, then decreases. It goes up to 0. In the period, the valency first increases and then decreases. The valency even goes up to 0. Why it is so? Because when we move from left to right in a period, there is an increase in the number of valence electrons and there is a decrease in the valency. But as the number of valence electrons are only increasing, valency is decreases, but the nuclear charge, that is the number of protons, are also increasing. When the number of protons are increasing, it will pull the electron closer to the nucleus. It will pull the electron closer to the nucleus and there will be decrease in the valency. The force of attraction will increase. The valency will decrease because the valency is the combining capacity of an element. The electrons that will become outermost electron become less and less, and in the period there will be decrease in the valency because there is a increase in the number of valence electron. Because there is a increase in the number of valence electron. But when move in a group, the valency remains same. Because group is having same number of valence electron. Because the number of valence electron are same. So the valency remains same. Valency depends upon number of valence electrons. Valency depends upon number of valence electron. I have also written in the group and period. Now, in the group, lithium, when I say lithium, sodium, potassium, all of them are having one valence electron. So the valency will remain same and the properties will remain same. Now I come to second trend in the modern periodic table. Now I come to second trend in the modern periodic table, that is atomic size. Atomic size is the distance from center of nucleus to the outermost shell. Atomic size is the distance from center of nucleus to that of a outermost shell. Now, when we move in a period, atomic size decreases. When we move in a period, atomic size decreases. When we move in a group, atomic size increases. It is very difficult to measure atomic size. It is measured in different manners. There are different type of atomic radii, but that is not in our syllabus. Like we are having van der Waals forces, we are having covalent radii, we are having ionic radii, we are having metallic radii, but that is not in our syllabus. So we only discuss here atomic size is the distance from the center of nucleus to the outermost shell. Now, in the period, atomic size decreases. Why there is a decrease in the atomic size? The number of electrons increases in a period. Electrons increases in a period. But when the number of electrons increases, number of protons also increases. Number of protons increases. But the most interesting thing is that the electrons are added in the same shell. The electrons are added in the same shell. Let me take an example of the second period: lithium, beryllium, boron, carbon, nitrogen, oxygen. 3 number of electrons are 3. In the outermost shell, number of electron is 1. The atomic number of beryllium is 4. The outermost electrons are 2. In boron, atomic number 5. The number of outermost electron 3. In carbon, it is 6. The outermost electron 4. In nitrogen 7. The outermost electron 5. In oxygen 8. The outermost electron 6. But all the electrons are present in the second shell. All the electrons are present in the second shell. Now, if the electrons are present in the second shell, that means if the electrons are increases, there will be increase in the number of protons also. There will be increase in the nuclear size. This nucleus will pull the electrons towards itself because the number of protons has been increases. This nucleus will pull the electron towards itself because there is a increase in the number of protons. The valence electron or the number of electrons increases. So the number of protons or nuclear charge increases. So there will be a greater force of attraction. There will be greater force of attraction which pulls the electron closer, and so there will be decrease in size while moving in a period. There will be decrease in size while moving in a period. But when we move in a group, there will be increase in atomic size. There will be increase in atomic size from top to bottom. Top to bottom. Why there is an increase in the size while moving in a group? Because number of shells are added. There will be 2 shells for lithium, that is 2, 1, first shell and second shell. There will be 3 shells for the sodium, that is atomic number 11, sodium, that is 281. There will be 3 shells. So naturally the size of sodium will be bigger than that of a lithium, because there is an increase in the number of shells. Because of the increase in the number of shells, the nucleus will be penetrated inside. And the nucleus, when it will be penetrated inside, there will be decrease in the force of attraction and there will be increase in size. There will be decrease in the force of attraction and there will be only decrease in the force of attraction. The nucleus is penetrated inside. The third property which you know about it, you have read it about the metallic and non-metallic characters. Metallic and non-metallic character. What are metals? Metals are those which can lose electron. Metals are those which can lose electron to make positively charged ions. So, when we move in a period, metallic character decreases, and non-metallic character increases. If we look at the third period, on the extreme left there is a sodium, and if we move towards the extreme right there is a chlorine, although after that there is a noble gas which is also a non-metal. Metallic character is also said to be electropositive character. And non-metallic character is said to be electronegative character. When we move in a period from left to right, there is a decrease in metallic character. The reason is same, because the electrons are added in the same shell. There is an increase in the force of attraction between the electrons and that of a nucleus. So it becomes difficult for element to lose the electron. Best metal is that which can lose electrons very easily. Now, when we move in a group, there is an increase in metallic character. Because there is an increase in number of shells. The nucleus is penetrated inside. There is a decrease in the force of attraction, and it will be only very much easier to take out outermost electron. But in the case of non-metals, the electrons are being gained. It becomes very much difficult to take the electron, as the number of valence electrons are present in the same shell. There is an increase in the force of attraction. So that is why it has become difficult to take out electrons. In the metals, when we move in a group, although there is an increase in the number of shells, there is an increase in the number of electrons, but the decrease in force of attraction dominated over the increase in the number of electrons. So the metallic characters, where when we move in a group, there is an increase in the metallic character, and when we move in a only period, there is an increase in the non-metallic character. So this was all about the trend in modern periodic table, although there are few more properties like electron gain enthalpy, ionization enthalpy, electronegativity. About these are also trend in periodic table, but in our syllabus we are having only three trends, and go through the chapter thoroughly, read notes thoroughly. If you are having any problem, let me know so that I would solve your that problem.